Hello, everybody. Hello, space fans, and welcome to the Friday Space Roundup here on Space Fan News. In this episode, we are going to be talking about two major stories that I've been following this week. The Hubble Space Telescope turns 30, if you can believe it, which I cannot. 30 years in orbit this week. It celebrates this amazing milestone. And also the Mars helicopter that we're going to be sending, that NASA's JPL is going to be sending to Mars, is now got a name. So we will talk about that as well. Hey guys, okay, so this is the first one. This is live. Everything that could go wrong will probably go wrong, but I'm hoping to doing this every Friday night at 8 p.m. Eastern Time, where we talk about the latest space news for the week. And this is also a chance, this is Space Fan News Live. This is also a chance for you to interact with me toward the end. So we will let me do the stories and then we'll interact. You can do that. I am broadcasting on YouTube, Twitch, Twitter, and Facebook, and I'm looking at all of the chats. I see Arctufus and Uncle Bill are both on Twitch, so welcome, and I will interact with you guys as the time goes on. So let me know what you think of this. If you like it, please feel free to share it and thumbs up it and all that great stuff that happens with these live streams, and I will continue to do them. Okay, so first up, the Hubble Space Telescope is 30 years old this week. On April 25th, 1990, NASA launched the Hubble Space Telescope for in orbit, where it has been ever since. It was designed, of course, to be serviced by the space shuttle. It was deployed by the space shuttle, and it was meant. In fact, I even have an image. There is an image of Hubble being deployed 30 years ago today. So that is how long it's been up there. And I got to say, with all of the trials and tribulations that Hubble has had over the years, and it's had many. Remember when maybe you don't remember because it was 30 years ago, but I'm old enough to remember that in the early 90s, after it was launched and deployed, it was found to have a primary mirror fault, or a flaw in the primary mirror known as spherical aberration. The mirror was made by Perkin-Elmer, and at the time it was a disaster because that was like telescope making 101 error there. So, but they were able to fix it with a later repair mission, STS. I forget which STS it was, but anyway, they went up and they fixed it. And after that, it was like a couple of years after launch, the Hubble Space Telescope has done nothing but dazzle us and give us amazing images of our place in the universe. And of course, the Hubble Space Telescope has a special place in my heart because that is where it inspired me to start making videos on YouTube way back in 2007 when I saw the first Hubble Deep Field image. So anybody who's followed me for any length of time knows that image is one of I believe is the most important image ever taken, because it provided us with a view of the heavens that is, if you know the context of the image, the way it was taken, then our place in the universe is forever etched in our minds, because the universe is full of galaxies. It looked at a tiny spot in the sky for 11 days where astronomers really did not know they would see anything at all. And out comes an image of thousands of galaxies. So, and the Hubble Space Telescope was initially launched with the science goal of, one of its many science goals, of helping us determine, or to narrow down the value of the Hubble constant, which is the number that's used to describe the rate of acceleration of the universe. So, and it did that very early on in its mission, and it's also done subsequent observations. Now, it has been serviced 5 times since it was launched, and every time it's been made better. The last time it was serviced was in 2009. John Grunsfeld and et al. Went up there in one of the last shuttle missions ever put up there. The space shuttle, I believe it was the Atlantis, did the final repair. They replaced everything, and basically when they left the Hubble Space Telescope, it was a completely new instrument. It had brand new cameras, brand new gyroscopes, all of that stuff right now. So one of the things that NASA does is every year, to mark the anniversary, every April, the third or fourth week in April, they issue an anniversary image. And so now I'm going to show you the video of that anniversary image. So here we go. This is the Hubble Space Telescope's 30th anniversary image.
The Hubble Space Telescope has given us an incredible image for its 30th birthday. This image reveals a beautiful nursery for new stars in a nearby satellite galaxy to our own Milky Way. The bright, newly formed stars in the middle of this image are at least 10 times more massive than our Sun. Powerful radiation from these stars is causing the surrounding gas to glow in stunning colors. The blue indicates oxygen gas heated to nearly 20,000 degrees Fahrenheit. The red indicates the presence of nitrogen and hydrogen. Those massive stars are also driving powerful winds of charged particles which are sculpting out the bubble and ridge structures we can see across the nebula. The blue nebula at the lower left of the image is actually material ejected from a single huge star in the center. That star is 200,000 times brighter than our Sun. The whole region shows how dynamic our universe is, with stars continuing to form and affect their surroundings, and it's Hubble's exquisite vision from its orbit above Earth's atmosphere that gives us the ability to get a clear glimpse of this kind of incredible beauty and activity. The Hubble Space Telescope has changed the way we think of space and our place in the universe. Hubble has refined our understanding of the age of the universe and its rate of expansion, and through its deep fields, it has peered across billions of light years to reveal ancient adolescent galaxies we can compare with our own Milky Way. It has shown us the telltale effects of mysterious dark energy and dark matter, and it has given us a front row seat to these beautiful interstellar clouds and nebulas where new stars and their surrounding disks of dust and planets continue to form. Hubble is in excellent technical health and is expected to continue its exploration of the universe for quite a few years to come. Multiple astronaut missions to service the Hubble Space Telescope over the years have kept Hubble at the forefront of capability. With each servicing mission, astronauts repaired or replaced instrumentation, keeping Hubble better than ever before. The final servicing mission in 2009 was extremely successful, so that even today, Hubble is more scientifically powerful and productive than ever before. You can find out more about the Hubble Space Telescope at the website nasa.gov/Hubble and on social media at NASA Hubble.
I love that video. That was really good. And I especially love that zoom in toward the end there. That really gives you a sense of just how narrow the field of view of the Hubble Space Telescope is. So here we are, 30 years in. So what's the latest on Hubble? Well, it's old. It's really old. And so it's still taking images. The main camera's Wide Field Camera 3. It's still out there. It's still taking data. One of the gyroscopes has died, but it still has 3 others, I believe. But they've got a special program in place where they operate it with 2 at a time whenever possible, so that they can save the length of the time of the gyros. The gyros are these things that allow the Hubble Space Telescope this ability to point very precisely, because you may not know this, but the field of view of the Hubble Space Telescope is so narrow that so small, it would be, imagine if you took a grain of sand from the beach and you held it out at arm's length up against the sky. That's the area of sky that the Hubble Space Telescope can see. So it's very, very, very narrow band, or narrow field of view. So and it needs precise pointing to be able to see that. So what we're all waiting for now is we're waiting for the James Webb Space Telescope to come along. This is going to be the successor to the Hubble Space Telescope. It is currently complete. The telescope is built. It has been tested and deployed several times, and the mirror itself has been unfolded, and it's being folded back up again now. It's scheduled for launch March of 2021. But you know what I'm going to say next, don't you? Yeah, it's probably going to be delayed. They've already delayed work because of the coronavirus pandemic. It is not being worked on right now. Northrop Grumman is the main contractor. It's all sitting at Redondo Beach, not getting worked on. So I would be shocked if we did not see a delay in launch. I think it will be delayed. My guess is it's going to be another year before it launches. So I'm saying March 2022. And it will probably cost another $500 million for the delay. It already has run $9 billion, but I would caution everybody about this, because yes, that's a lot of money. I get that. It's what an aircraft carrier costs. But in $1990, the Hubble Space Telescope, I think, was like something in the order of $2 or $3 billion in today's money. So it was pretty expensive. That was a pretty expensive telescope. It had cost overruns, and then when it was launched, it also had problems and needed to be repaired. The James Webb Space Telescope is not designed to be repaired. It's going to the L2 point, which is a point 1.5 million kilometers away, past the orbit of the moon, where it will follow the Earth as it goes around the sun. So look for this telescope coming up in a couple of years. Well, okay, at least a year. So anyhow, okay, so next story I want to talk about is, did you guys know, because I recently found out about this, but NASA and the Jet Propulsion Laboratory are planning on sending a helicopter to Mars. Check this out. I know, right? That looks awesome. Now, did you see that part in there where it was flying in a vacuum chamber? It wasn't a vacuum chamber, but a chamber that simulated the atmospheric pressure on Mars. Because what I find very surprising about this is Mars has a very thin atmosphere, and that they can make this fly. But it has been tested, and it is ready to go, or at least it is getting ready to go. And the big news this week was that the helicopter now has a name. An Alabama high school student names a NASA's Mars helicopter. Vanessa Rupani, she's a junior at Tuscaloosa County High School in Northport, Alabama, came up with the name Ingenuity for NASA's Mars helicopter. And there's an artist's impression of it right there. So that's that just happened this week. So let's take a look at some of the things that Ingenuity can do. Right now it's a technology demonstration, which for making sure we can fly on Mars. Okay, this is going to be a test thing. We've done rovers. We've got lots of rovers out there. We've got pretty good experience, or at least NASA has pretty good experience with rovers, and now they are graduating, if you want to call it that, with the with flying devices. It looks like a really big drone. And it's going to be attached to the belly of the Perseverance rover. It's scheduled to be launched later this summer, between July and August 5th, 2020, from Cape Canaveral here in Florida, and is expected to land on Mars in February 18th, 2021. It will go to the Jezero crater on Mars, and it will basically, the idea is to have one or more flights within 30 days of getting there. So here's some of the facts about it. It's a small autonomous aircraft that will be carried to the surface of the red planet, attached to the belly of the Mars 2020 rover. Its mission is experimental in nature and completely independent of the Mars 2020 science mission, which means that this is just one aspect of it, and the mission won't be in jeopardy if this doesn't fly. And the months after landing, the helicopter will be placed on the surface to test, and for the first time ever, a powered flight in the thin Martian air. So, wow, I'm very excited about that. And so these powered unmanned rovers that we're sending out to Mars are really starting to give us a lot of good information about Mars. So I'm very excited about that. So, okay, so this was my first one, my first Space Fan News live space news roundup. I've been working all day getting this set up, and so I was able to get two stories put together to present to you today. As we go along with this, I'll get more practice and I'll have more stories queued up for you. So what I'd like to do now is I'm going to close out this segment, and then I'm going to stay here, and then I'm going to get to your questions and answers. We're going to start the live portion. So here is my outro. Okay, so there we go. Like I said, I'll get better at this. There's a lot of buttons to push when you're doing this live. So I'm streaming on YouTube, Twitter, Twitch, and Facebook. So I'm looking at all of your comments here. Galaxia, you made it. It's late where you are. Architufus is here on Twitch. So, well, thanks, Disillusioned. I forgot you are already confused by the Twitch handle because I forgot to change the title. When I started the stream, it still said Tony's Twitch Tuesday, which, by the way, if you're watching this, you should check out on Tuesdays, 3:00 Eastern time. So I'm going to be doing more of these. I'll have more stories. If you would like to suggest stories for me to do on Space Fan News, please consider going on the Discord server, which Uncle Bill has posted, and also Stream Elements, my bot, is also posting. Join it and suggest stories that you'd like to see, and I will try to add them in. This week I had a lot of setup to do that I don't ordinarily have to do. So next week will go hopefully a lot smoother. So anyway. I don't think it has any payload capacity for solar panels, but don't quote me on that. It does not, Architufus. Let's take a quick look at the... let's go back and just take a quick look at... Where was it? Here it is. Let's see what we can find. I don't see any solar panels, but let's look at some key features. It weighs 4 pounds. Oh, it is solar powered, and it recharges on its own. It's got wireless communication system. It's got two 4-foot long, 1.2 meter rotors. So that's, those rotors are a meter. Well, wait a minute. 1.2 meter long rotors. So each of these are a meter long. Each of those. So that's pretty cool. It goes up to 2,400 revolutions per minute. and it's equipped with inertial sensors, a laser altimeter, 2 cameras, a color one and a black and white one. Basically, it's a really fancy drone designed to go up. And I'll bet what they did was they probably ordered one of those professional ones, that you can get for like making movies and stuff, and change the rotors. How much you want to bet? They didn't do that, I'm sure. And here's the key objectives: is to prove that powered flight can be done in the thin atmosphere of Mars. So I don't know if you guys remember Sojourner, but Sojourner was, I think, the very first rover that we had sent to Mars, and it landed in a big balloon kind of thing where it was inflated and it just basically bounced on the surface and then deflated and out it, and then it came out. That was the first proof of concept rover that we ever had. So this will take that place. This is kind of like Sojourner in the sense that it's a proof of concept to make sure we can fly. It's going to demonstrate some of the flying technology that requires shrinking down the onboard computers and all that kind of stuff, and it's supposed to operate autonomously because controlling it, there's a big time delay between Earth and Mars, so you can't have a joystick like a drone operator or a what do they call those? What do they call those aircraft that the military uses? I'm drawing a blank, but you know what I'm talking about. These remote-controlled aircraft that they use to shoot people down with. Those can be done on joysticks from anywhere on the planet, but when you're talking about Mars, you can't really do that. The helicopter will use solar power to charge its batteries and rely on internal heaters to maintain operational temperatures during the cold Martian nights. After receiving commands from Earth relayed through the rover, each test flight is performed without real-time input from Mars helicopter mission controllers. So that's what it's going to do. I think it looks pretty cool. I don't see the solar panels are up here, man. There they are, Arctufus. You see them? They're up here. So those must be the solar panels there. So cool. All right. Predator. Thank you, Lane. Yes. What do we call those drones? Are they drones? But the Predator is what I was thinking of. That's the name of it, but I don't think. Well, let's see. What are the cameras? It doesn't say actually. It doesn't really say what the cameras are in the. Nope, doesn't say. So I don't know what the camera. What the cameras are. Oh, here's the technical specs. Let's look at that. Here, let's go over here. Do you guys want to play the Coda Mars helicopter video game? No. Let's go over here to the tech specs. Let's see. Oh, those are pretty sparse. So it's got lithium-ion batteries, 350 watts of power during the flight. 4 pounds on Earth, 1.5 pounds on Mars. Well, that is lame. Those are the technical specs? Huh. Okay. Well, anatomy. Let's look at the anatomy. Hover or click on the orange dots to learn more. Batteries. Sensors and cameras. Let's click on that orange dot. Still not telling us. Wow, this is really lame. There's the antennas and there's the solar panel. Oh, come on, man. Cameras help the helicopter to see. Well, okay. So there you go, guys. Flight altitude 15 meters. I didn't see that. Blades. Oh yeah, up to 5 meters. They're planning on, and the flight range will be 300 meters. So yeah, but it doesn't say anything about the camera resolution or what it's got on there. So we have to look somewhere else for those. Well, I mean, hey, the fact that it's flying at all disillusioned is pretty good, right? I mean, that's what we should be looking at. The fact that this is happening, it's just a proof of concept because it's a Pathfinder mission. That's what they're called. Asteroid Hunters. Hey, Mike. NASA's just looking for an excuse to fly an RC helicopter and do some flips on another planet. Yeah, man, that's true. That's very true. So they just want to play. I know I do. That's all I want to do is play. So, all right. Well, let's see. Okay, so yeah, maybe I guess so, Lance. I don't know what the deal is there. How much RPM will they need to generate lift? Well, it says up to 2400 RPM. So JD wants to know why I did not pursue grad school in astronomy after getting a physics degree. Okay, I'll tell you why, JD. Tony D is going to talk to JD for just a moment. Okay, so let's set the Wayback Machine to the late 90s, early 2000s, right? I'm in college. I don't start college until I'm 30 years old, okay? I have two children. My youngest son was born on the week that my first class started. My first class was, or my son was born May 26th, my youngest son, and I started school a week later. He was, because his mother was Jewish, he was born Jewish, and his bris was held the day I started school, and I had to ask permission to not go to the first day of school because of his bris. And this was a theme throughout my education, right? I had a family, I had to support, and so I worked very hard through a lot of support. I was able to get through the physics degree in the bachelor's degree at the University of Colorado. Well, it took everything I had to get through that degree. I mean, I could do nothing else. I mean, I was able to spend time with the kids, and but it was not as much as I would have liked or they would have liked. I was spending 20 hours a week on problem sets. I was spending easily that much time in lectures and going to class and driving around and parking and that. And then I had a part-time job at the High Altitude Observatory where I was working for 20 hours a week as well as a student assistant to earn some money in addition to the grants that I was getting. And I was applying for a lot of grants. So I work hard. I had a decent grade point average. I made the dean's list a few times, and I graduated, I think, with really in the high 3 point somethings. I forget what it was. Doesn't matter anymore. But I did okay, right? I got the degree. But when the time came to decide to go to grad school, which was, I had been at this 4.5 years, because one thing I did is I put off taking freshman chemistry because I just hated it. And I didn't take freshman chemistry until the very last minute. It was the last course I had ever taken. Imagine you're a senior in physics and you're getting ready to graduate, and all of a sudden you're back in a freshman level class taking chemistry. And I was miserable. What a mistake that was. But I needed it to graduate. Not only that, I needed 2 semesters. Each one was 5 credit hours each, for a total of 10 credit hours I needed to graduate. And so I was getting sick of doing homework and problem sets and lectures and all of this kind of stuff. To go into grad school, I needed to decide soon, relatively soon, because if you wait too long, you forget all that stuff, right? Because my mind was primed. I had all that math in my head. I had all these classes in my head. I had just finished taking some really hard physics courses, and it was all still jammed in there. But if I had waited a year, it would have all gone away, and I needed to keep it. You know why? Because you have to, in the United States of America, you have to take this stupid thing called a GRE. And the physics GRE is incredibly hard. And I looked at that and I'm going, do I really want to take the physics GRE? And it's just one of those, it's just an obstacle. It does, the GRE, this is my personal opinion, does nothing to prepare you or indicate how well you're going to do in grad school. It has nothing to say about it. All it does is it just tells you can take a very hard test. That's the only thing that the GRE tells prospective graduate programs, and yet they require for you to be a part of their program that you score a certain amount on the GRE or they won't even look at you. So I'm thinking to myself, do I really want to take this stupid test and then maybe several times, right, before I pass it? Because it's hard, right? And it's like everything you've ever learned in physics over 4 years, you've got to be able to recall it and do it quite well, and you've got to do it within a reasonable amount of time. It's a time test. on top of all the other fun stuff that the GRE is. So I thought about that, and then I had to think about, well, where am I going to go? And then I realized that if I just stayed at the University of Colorado, because remember, I have a family, moving is a big deal. So I needed to stay where I was. And the University of Colorado, while it has an excellent graduate school program in astrophysics, which is what I would have done, it required 2 years worth of comps, what they call, you had to take 2 years worth of coursework at the graduate level, and then you had to pass this thing called comps, which is another level of testing, standardized testing that you have to pass in order to get your master's degree. Once you've gotten your master's degree, then you get the fun part of being a graduate student and joining and becoming, getting an advisor and starting your PhD thesis. So GRE, another 2 more years of really hard college classes. Then you got comps to take so that you get your master's, and then finally you get the joy of the PhD. And I asked myself, do I really want that PhD? What's it going to get me that I can't get elsewhere? And the answer was, well, it could make me an astronomer with a capital A. Boop. And that would have been great. But then I saw the people who were astronomers with a capital A becoming postdocs, and the amount of stress that they were under after they got their PhD to not only find a place to work, but their publishing requirements were quite high, and the stress level was amazingly high. And guess what? I was already earning more than them because I had gotten a job as a software engineer before I graduated at the High Altitude Observatory, where my salary was already greater than every postdoc that ever came along. And I'm thinking, okay, gee, a whole lot of work, basically slave labor and low pay or no pay. Do I really want this? And the answer was no. And I never regretted it. It was not something I ever look back on and say to myself, boy, I sure wish I had that PhD, because my career was full. I did everything I wanted to do. I got to work in telescopes and observatories around the world. I got to build cameras. I got to program cameras that took amazing astronomical images. I got to process that data. I got to write pipelines that served that data. I was able to be involved in every aspect of the field of astronomy, professional astronomy, without that degree. And up until a postdoc is able to finally get to the point where they are in a tenured position, only then did they start making more money than me. And that was after at least another decade, right? And then they were actually making more money than me, and they were serving on committees, and they were having all this responsibility. They were project scientists for blah, 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 this and that and the other thing. Lots of prestige, but you know what? They deserve it. Good on them. They get to have it, because getting there was not easy. And me, I earned a decent money the entire time. I don't think I ever, by the time I left, my career culminated with working on the Hubble Space Telescope. And I swear to God, it doesn't get any better than that. And by the time I left, I was making over six figures. Okay. So that's pretty good money. And so it was the story of my career is one that you could look at and say, you don't have to get the PhD. If you want the PhD, go for it, but don't do it for any other reason than because you want it, because you are in for a lot of pain otherwise. So that's my story of why I did it. Yeah, I've told this story many times, Neil, but it's it's one that I don't mind sharing periodically, just because I think it's important. There are other alternatives to getting to working in astronomy that don't require getting a PhD, that are very fulfilling and very less stressful. Stress was always a big factor for me. I always have tried to live a life that has been low stress. And if I could see the people going through a lot of the heavy duty stuff and just going mentally drained, right? And so I look at them and go, thank God that's not me. Sure, but I never got the prestige, right? I never got to be like, I don't know, Alan Stern, who who led New Horizons mission to Pluto, or John Mather, who won the Nobel Prize and later is now the project scientist for the James Webb Space Telescope, or Carol Christian, my friend and colleague, who is the project scientist for the Hubble Space Telescope. So I never got any of that, but that's okay. I got a lot of kudos anyway because the work I did was vital to many projects, and without which they could not have been done. And so, and with my colleagues, I was always given good feedback, and that was always enough for me. So, yeah. Hey, James, it's good to see you, man. It's good to see you again. I have been streaming for a bit. I'll be better next week about. Well, I did start at 8 o'clock, but I'll be a little bit more forthcoming with better stories. And like this time, it only took like 15 or 20 minutes, and then the chat started. The format's going to be this: I'm going to make two. I'll have two, maybe three stories that I prepare for in advance. We talk about. I'll present them to you, and then hopefully we'll talk about them during our chat and the remaining time that we have. So that's going to be when I'm doing it. And thank you, Susan. Yes. Thank you, man. Thank you so much, Susan. You've always been such a great supporter of the channel, and I want to invite all of you. It turns out that what you're doing with support in the live chats, both on YouTube and on Twitch, the super chats on YouTube and subscribing on Twitch really does help. I suspended the Patreon campaign that I had for Deep Astronomy because I felt really strongly that I did not want to compel people to support during a time of possible financial hardship, and to give people the freedom to do that. So there's other mechanisms if you want to support and you're able to. I certainly would appreciate it. If you go to deepastronomy.com/donate, you can just do a $1 thing or whatever on PayPal and Stripe if you don't want to deal with any of these platforms or any of that other stuff. So there's another way to do it. So James, it's really I'm here. James, I'm here for you mostly because what you said in the Discord server. I felt bad for leaving YouTube and leaving all the people here. And I really do have a pretty big audience here. Today I've got there's about 40 people watching right now, but other times when I start building this up, hopefully that'll grow. But I don't use this channel as much as I should, maybe because it just seems so YouTube is just so hard to do to deal with all of its stuff. Like, I'll bet you after I'm done with this stream, I'm going to get a copyright violation, and you know where it'll come from? Those NASA videos that I showed you. As soon as I stop the stream, I'm going to get an email that says there's a copyright violation on your latest stream. Don't worry, you don't need to do anything. We're just going to put ads on it that other people will get money for that you won't get money for because you used content that somebody else says they own when they don't. So you watch, it'll happen. And so that's really one of the reasons why I've just, I'm trying to do Twitch more, and I will do Twitch more, but YouTube I won't forget either. And because of you, James. So thank you, man. No, yeah, fair use, of course, Third Rock. But the thing is, this is all public domain. What I just showed you was produced by NASA and JPL, right? And because it's taxpayer funded, this stuff is. You can use it so long as you credit NASA and JPL for their use. That's all you have to do. But who else uses this stuff? Well, let me show you something. Here I have, look at what CNN has done here. So let me get rid of Anderson Cooper here. So CNN also has a story on the chopper, right? And embedded in here somewhere, well, there's the girl. There's Vanessa Rupani who chose the name. But there is somewhere in here probably a video, or maybe they posted it somewhere else. But I'll bet you that they're using all of this content, right? And this is CNN's website. And so they are going to get, because YouTube likes CNN and wants them to be, give them more money, they will get the credit for owning that video even though they don't. And so I've got to fight it. So there we go. Anyway, James, don't worry about it, man. I see you disillusioned. I see you right there. I am everywhere, man. I am on Twitch. I am on Twitter, and I mean Facebook. I'm on this too. You know what though? Nobody's watching on Facebook. Let me see how many are looking on Facebook. I think 2 or 3 people. Facebook is quite lame. One person's watching on Facebook. Nobody's watching on Periscope. So there you go. It's just all about Twitch. 40 on YouTube and 10 on Twitch. And but I got you all, man. I got you all right here. So there you go. We do need a union, man. That'd be a good idea. How are you? How are you supporting? You've been if you've been supporting him, you probably, it's probably it doesn't say who gets the money. Well, if you do things on Super Chat, then the creator gets all of it. If it's through ads, YouTube takes a chunk of that money, and they don't tell you how much they take. And so, and then of course you can donate directly. Either if they have a Patreon account, which Patreon takes money, a chunk of that, or you could just give me, if you wanted to donate, just go straight to my PayPal account, which is on my website, and just do it there. But then PayPal charges too. I think like 1% or something. So anyway, yeah, the ads they don't say how much they YouTube takes, and I don't think Twitch does either. Twitch takes some money out of your pocket as well. So. All right. Any questions, guys? Let's see. So Tony, the shielding on Hubble, is that more for cosmic rays or is it more for temperature countermeasures? Yeah, you can't shield against cosmic rays all that effectively. But it does. Yeah. Are you talking about like this? Are you talking about like this, where it's got this reflective coating on the outside, or this reflective surface? That is just to keep it, to help the temperature control. There is because you think about it, the difference between the daytime side of the Earth, it goes around the Earth once every 90 minutes, and so the difference in temperature is several hundred degrees between the daytime and the nighttime side. So there needs to be some temperature compensation built into this thing, and I don't know enough of the details to know how it's being cooled, but yeah, this is mostly for temperature reflection. And that flap on the end of the objective tube, on the optical tube assembly, that has never once been closed. I think JWST obviously doesn't have one. It's an open truss design, but they put that on there, I guess, for launch, just to protect it from stuff coming out of the cargo bay of the shuttle. And they opened it, and then they've never closed it since, and they won't ever close it, they told me, because they're worried it won't open again. So could you imagine, you close this down for whatever reason, let's say you're going to look through the sun or pass through the sun or whatever, you close that up and then it doesn't open again. You've got this multi-$100 million instrument at the mercy of a flap that won't open. So they won't ever close that again. But they also don't go anywhere near the sun with this as well. So okay, let's see. Hey Dan, it's good to see you too, man. My Canadian friends, asking a stupid question: why not just do e-transfers? No one can get into your account. I would do that. Oh, because the banking system in the United States of America is based on 19th century technology. We still write checks in this country, and to do any kind of electronic transfer is a real. My wife has a term for this. She's from England, but it starts with an F and ends with an O. And it's a real problem. And so you'd think the things that are easy, like doing a bank transfer, would be trivial, but it's not in the United States of America, because our banks are still using paper and everything else, and doing anything internationally is just a complete mess. I use TransferWise. TransferWise is probably the best way to send money overseas. You could send money in dollars, and you can send it to any currency you want, to any bank and sort code in the world, for a reasonable fee. I mean, they give you a pretty good transfer rate, or a pretty good a pretty good deal on your money. And I've never had a problem with it. I always send a lot of money back to England, and so I'm transferring to pounds a lot. And I've always used TransferWise, so I look into that. Can I get my telescope up there as well? Oh, hey Kenneth, welcome. It's good to see you from the Philippines. Oh, Sagnostic. Do you really want to go there? Do you really want to talk about flat Earth? Uh, oh, I'm so late. So, are you trying to view the SpaceX astronaut test? Praying for success. Hey, Susan. Yeah. So that launch is going to be later this month. I would like to try and go see it. There's not going to, obviously, with the coronavirus lockdown and stuff, it might not. It might. NASA is telling people not to go to the launch. They're trying to tell people to stay away. However, I have a boat, and I would love to go to the Mosquito Lagoon, which is just outside of the NASA launch area. And I'm thinking of taking my boat there and trying to see it from there. That's plenty of good social distancing. I'm not going to be near anybody, and I should be able to see the launch. But yeah, man, it's going to be a tense time. It's going to be really tense. First time we've launched human beings from this soil of the United States of America since this last space shuttle mission, and so it's been a long time, and so I'm excited about it. I really am. I hope. I mean, I have my issues with Elon Musk, but I'm really wishing him nothing but success here. So we need online voting for what? You mean for like the president and stuff? We need a cargo ship that's just like a remote site with many telescopes we can remote into. Yeah, well, hey, have you heard of SpaceFab? SpaceFab is launching an 8-inch, I think it's a Cassegrain. Maybe it's not a Cass. No, it's a Dahl-Kirkham, I think, telescope that is going to be available to amateur astronomers. So spacefab.us, check them out. They're building it now. It's going to be, they're associated with OPT. In fact, ex-OPT employees started this company, and I'm excited about that. So there's a possibility of a space telescope being available to amateurs. And you can also, they're designing it so that you can actually look at things on the Earth too, so you can take a selfie from space. However, I have reservations that they're going to be allowed to do that. I think that there's going to be a lot of national security problems with pointing a 8-inch telescope toward the Earth, especially a high resolution one. Take Cash App. I've heard about it, Neil. I don't know much about it, but I need to look into it because that's something that I guess people are making money out with on Instagram as well. So super expensive to use though. What is the Space Fab? Yeah. Yeah, so Susan, yeah, I'm gonna be unless they can make virtual chats. I don't know what's gonna happen with the election this year. We're getting off topic here, but I'm hoping that we are allowed to actually vote. But that's a little bit off topic there. So what do you guys there is one thing I can try. I was gonna set this up, but I did not do it. Give me just a brief moment here. See if I can do this without disrupting. Oh, I cannot. Pushing buttons, yes I am. All right. Now. Here we go. All right. Before I leave you guys, let's talk a little bit about what's up tonight. Is my cursor showing up? Yeah, it is. All right. So let's do a little star talk here. This is tonight at about now. It's actually a few minutes ago because I hit the J button and it went back a little bit. This is tonight in the West and the Northern Hemisphere. Sorry, James, this is not something that's going to help you. Although I should enter in Australia. If you're looking west, that very bright thing in the sky that you may have seen out there, that is Venus. And Venus is very high in the sky this time of year. The orbit of Venus is inclined. It goes, because I can actually see my cursor. The orbit of Venus kind of does this kind of thing, and it will. Right now, it's very high up in the sky. It's the elongation of the orbit puts it very high in our sky this time of night. And Venus is something you definitely want to check out. And you can also see that there are several constellations that are out as well. The constellation of Orion is saying goodbye this time of year, early in the evening. Taurus, the bull, is also setting low in the sky this evening. So that is, as the sun goes down, so too do Orion and Taurus. But you can still see, looking in the west, the brightest star in the night sky, which is Sirius. And looking south, which is always the funnest place to look, we have not a whole lot. Usually this time of year, later tonight, should be able to see Scorpio. But let's go look east a bit. What's rising? Arcturus, the red giant star, which is very, very bright in the eastern sky. It's part of the constellation of Bootes. And looking north is the Big Dipper and the Little Dipper. And one of the things I always like to do is if you're not sure how to find Arcturus, you can look at the Big Dipper right here, and you see the handle of the Big Dipper, and you just arc to Arcturus. And there is how you find it. So it's always a good idea to double check. When you see a bright star, you go, I think that's Arcturus, but how would I know for sure? Well, can I arc to it from the Big Dipper? The Big Dipper is very high in the sky right now. And some really cool things to see in there. Most notably is a spiral galaxy called M57, the Whirlpool Galaxy. And there is Polaris, the North Star. It is not the brightest star in the sky, but it is actually a variable star. It's pretty hard to see. And so to actually find the North Star, what a lot of people do is they look at the Big Dipper, which is almost always the easiest constellation to see because the stars that make it up are so bright, and you use these two stars here, which are called the pointer stars, and they point right to Polaris, the North Star. All the constellations go around this star. Let me speed up the night. This is the Earth turning underneath the stars, and you can see that one star is not moving very much. It's because all the other stars are going around it. All these constellations that are in this region of the sky are called circumpolar because they go around the pole. There's Cepheus, Draco the Dragon, and many others. So there we are. That is a brief intro into what's up tonight. So hopefully if you guys go outside, you can see some of these constellations for yourself. Now most of you I know watching this know all this stuff. So I'm not telling you anything you don't already know. But it's still kind of cool just to look real quick and see what's up. All right. Any news on Betelgeuse? I think it's getting back to its normal brightness. The scuttlebutt was that there was some dust in between us and Betelgeuse that was causing that dimming to begin with, and I guess now it's returning to its normal brightness. But something about that has been bugging me. If it is Betelgeuse, that is, if it's dust between us and Betelgeuse that's causing that dimming, this isn't like clouds in the sky we're talking about here. This is gas and dust in the interstellar medium, right? So it has to be that this stuff is moving, glacially slow, and that as the Earth goes around the sun, that motion is enough to cause it to get into and out of some line of sight of some of that gas. Because I just can't imagine that gas moving that quickly. But, what do I know? I mean, it could be. But I just wonder about that. I'm wondering if this gas moving into and out of our field, our line of sight between Betelgeuse and us, isn't more caused by our motion around the sun than the motion of the gas itself in between our line of sight. It could be. I mean, it could be that right now just enough of it has gone in, and then it's very wispy, and more. It'll keep passing through. I don't know how fast gas and dust moves, but you think about it, it's got to move through light years of distance, but by the time it makes any kind of impact, wouldn't it? I don't know. I'm just saying. Uncle Bill says the way I read it, it was burped out of the star itself. Okay, so there we go. Maybe something happened, some seismic activity in the star itself caused an ejection of some sort of gas from the star, in which case that would happen on time scales of months, I would think. So, yeah. So thank you, Uncle Bill. That's... Yeah, definitely sub to Asteroid Hunters, man. You're gonna like what he does. He live streams all of his asteroid observations from his very amazing control center, which you will see on Twitch tonight. So definitely, if you haven't subscribed to Asteroid Hunters and you care about near Earth objects, this guy's doing real science, right? He's actually plotting, and he's got an official observatory code that he puts in his data into the professional astronomers databases. So his name's Mike. He's a good guy. I highly recommend that you follow him. And he mostly streams on Twitch, but he also has a YouTube channel that he posts on as well. So definitely, Susan, you won't regret it watching what he does. So he's a really good guy. Okay, so I think, guys, I'm going to go ahead and stop. It's been about an hour. I'll be back next Friday with another Friday Space Roundup. I'll be a little more polished next time. It just takes practice. I had a lot of prep I had to do it kind of left me a little bit unprepared, but I'm going to come back next week with more preparedness. And who knows, by the time this is all done, I will be able to make a live stream that I could actually record, post, and edit as if I had done it sitting in my office from before. So anyway, all right, Timothy, yes, definitely go and check them out. You need to be made a mod. Hang on, just don't go anywhere yet, Uncle Bill. Let me find you where you is. I gotta find you, man. Where are you? There you are, Uncle Bill. All right. Add moderator. All right, Uncle Bill, you should be a mod now. I already made Galaxy a mod. James Dugan is a mod. Susan, you want to be a mod? Let's see. You don't have to do anything with it, Susan, but you're a mod now too. So, okay. So there you go. All right. Anyway, that is it for this week, Space Fans. I will be back next week, same time. We'll talk about what's up in the universe. I won't always do space exploration related stuff like I did tonight with spacecraft and stuff. Sometimes I'll do some science and astronomy discoveries as well. So if you have an idea for a story you'd like to see, go to my Discord server and go into space chat or live stream chat and post some ideas. I'll look at that every single day. So thank you all so very much. Uncle Bill, thank you guys for showing up. Neil, Timothy, Susan, thank you for the support. All of you guys, thank you for being here. Let me know what you think. Like this, share it, let your friends know. Mike from Asteroid Hunters, thanks for showing up. I will see you all next week. And as always, keep looking up.